By making use of the process of mathematical induction, I'm supposed to prove that this is true for all positive integer values of n. So we let Pn be this, and what we'll do first is to prove that for the smallest possible integer value of n, it is going to be true. And that smallest positive integer is 1. So I'm going to go for P1. And on the left hand side of P1, what we will be having is a summation of r equal to 1 all the way to 1 of sine r theta. And to evaluate this, I must first recognize that theta over here is independent of r. So there's only one single term, which is sine 1 theta, and that is when r is equal to 1 and ending also at r is equal to 1. And this is just sine theta. And on the right hand side, what we have is cosine half theta minus cosine of replacing n by 1. So 1 plus half theta divided by 2 sine half theta. So this is cosine half theta minus cosine 3 over 2 theta divided by 2 sine half theta. To continue from here, I'm going to make use of the factor formula that it can be found in the formula sheet. Using the factor formula for this, it is going to be minus 2 sine half of this angle plus this angle. So half theta plus 3 over 2 theta. And sine half of this angle minus this angle, which is going to be half theta minus 3 over 2 theta. And this divided by 2 sine half theta. And what we'll be getting is a minus 2 sine, this is going to be theta, and this is going to be minus half theta divided by 2 sine half theta. This is minus 2 sine theta, and sine negative of an angle is negative sine of the angle divided by 2 sine half theta. So in the numerator, we will have 2 sine theta sine half theta divided by 2 sine half theta. So sine half theta will be cancelled, 2 and 2 will be cancelled. I'll be left with sine theta, which is equal to the left hand side. So what we have done so far is to prove that P1 is true. And since P1 is true, I'm going to make an assumption. I'm going to assume that Pk is true. So let me write it down here. I'm going to assume that Pk is true for some k that will also belong to a positive integer, which means that I'm assuming that the summation of r equal to 1 to k of sine r theta is going to be equal to cosine half theta minus cosine k plus half theta divided by 2 sine half theta. And what is my next aim? My next aim is to prove that Pk plus 1 is true by making use of the fact that Pk has already been assumed to be true. So let me write down that aim here. My aim now is to prove that Pk plus 1 is true. That means I'm assuming that the summation of r is equal to 1 to k plus 1 of sine r theta can be proven to become cosine half theta minus cosine of k plus 1 plus half. So it is k plus 3 over 2 theta divided by 2 sine half theta. We have to prove that this is true. But we cannot just simply prove that this is equal to this just like that. We want to make use of the fact that Pk has already been assumed true. So I need to bring in Pk into whatever that I have here. To do that, I'm going to start off with the left hand side, which is a summation from r is equal to 1 to k plus 1 of sine r theta, and breaking up this summation into two parts. I'll sum it from 1 all the way until k, missing that last term. Then plus that last term, that is when r is equal to k plus 1. So it is sine of k plus 1 theta. And now here is the same as what we have on the left hand side of pk, and that is how we can bring in the truth of pk into the proving of pk plus 1. So this is equal to, I'm going to make use of what I've assumed that it is. It is cosine half theta minus cosine of k plus half theta divided by 2 sine half theta, then plus sine k plus 1 theta. I'm going to combine this into one single expression because I can see this is one single expression with the denominator as 2 sine half theta. So let's combine this together. It is going to be cosine half theta minus cosine of k plus half theta plus 2 sine of k plus 1 theta sine half theta divided by 2 sine half theta. And to continue from here, what I'm going to make use of is once again the factor formula that can be found in the formula sheet. And the factor formula that I'm going to be using is cosine p minus cosine q is equal to minus 2 sine half p plus q and sine half p minus q. I need a negative here, so let's bring out a negative. So it is cosine half theta minus cosine k plus half theta minus of minus 2 sine k plus 1 theta sine half theta, and this can be divided by 2 sine half theta. Our next question is, how can I then change from here back to here? Because I think it is probably easier for most of us to go from here to here, which is what we have already done, in this part of the question. So going from here back to here, right? If you can observe this together with me, can you see that this half p plus q and this half p minus q, if I were to add this to this, I'm actually going to be getting the angle here, because half p plus half q plus half p minus half q is p. So this plus this is this, and this minus this is actually this. So I'm going to make use of this observation to re-express this from this side back to this side. So it is cosine half theta minus k plus half theta minus this that is here, it is going to be cosine of this plus this. So it is going to be cosine of this plus this, k plus 1 theta plus half theta. Then minus cosine of this minus this. So it is going to be cosine of k plus 1 theta minus half theta. And this is to be divided by 2 sine half theta. So this is cosine half theta minus cosine k plus half theta minus this is going to be cosine of k plus 1 plus half. It will be cosine k plus 3 over 2 theta minus minus becomes half. Cosine of k plus 1 minus half, it is going to be k plus half theta. And this is divided by 2 sine half theta. So this and this can be cancelled. What I have left with is going to be cosine half theta minus cosine k plus 3 over 2 theta divided by 2 sine half theta. And this is what we have started out to prove. So what we have done so far is to prove that k plus 1 is true if pk is true. And this is a very, very important relationship that we have established, because what we have done so far is to show that as long as the previous proposition is true, it's going to cause the next proposition to become true. So since when we started out, we have proven that P1 is true. So together with this relationship that we have formed, if P1 is true, it's going to tell me that P2 is true. If P2 is true, it's going to tell me that P3 is true. And P3 is true, it's going to tell me that P4 is true, and so on. That is why we have already proven that Pn is true for all n that belongs to a positive integer. So I'm going to write that final conclusion. Since P1 is true, So by the process of mathematical induction, we can say that Pn is true for n to be any positive integer.